Okay, so hello, my name is Raul Rodriguez. Um, in this video, I want to talk about a situation and plant a problem or a case that has to do mainly with my major, or the thing that I want to study, and give every all of the details that have to do with it to try to explain exactly what does it mean, where to everything goes, give a little bit of explanation about the things that it has to involve, and at the end give some recommendations of what in this case has to be done. So firstly, I want to talk about a little bit about myself. My name is Raul Rodriguez. I live here on Monterrey, Nuevo León. I'm currently studying in my third semester, and my ID is A01571600. That's my ID. And the major that I want to study, and the one that I decided since my first semester, is the Bachelor in Mechatronics Engineering, since I liked so much about the area of robotics and everything that has to do involved with it. I've been a robotics person since my first semester on high school, being in a robotics team, and now that I do my work as a mentor of that same team. So I've created a very huge interest for the robotics, for mechatronics, and everything revolving around it. So this is why the major that I wanted to study is this one. So in this case, given the situation that we have been proposed and everything that we have to explain, I want to settle a case that has to do with this major. In this case, with any type of industry, any type of factory that wants to create a sort of arm, in this case, to create in a linear system or a linear way of producing, to make a simple task with that arm, either to get one thing to another place, to make sure that something has a certain object there, making it all of the times consistently and with no margin of error. So in this case, for example, in taking one thing from one place to another, which is a normal task that an arm will have to do, and the major of mechatronics engineering has a lot to do with this type of systems. In this case, it will be a five articulations arm, going from the beginning of the arm to the second part all the way until the wrist. Also making the changes from one side to another, either to the left or to the right, or to the bottom onto the top. And in this case, it will be just a type of claw that can make sure to grab something from one side and take it to another. So in this case, there is so many applications that have to do with the major of mechatronics, making this type of systems that consistently work, make the same time fast and efficiently all the time, takes a lot of precautions, a lot of things to consider at the time. And firstly, going just directly with the design of the arm, everything should be considered of what are the dimensions that I want, what is specifically the movement that you want the thing to do, if every sort of articulation is needed, what are the materials that are going to be needed, which is something very important. And in this case, it should be beginning with lots and lots of prototyping, making sure that we find the best way to do it possible, making sure that everything will be completely working at all times and no need to make any maintenance to the arm. So that's why the prototyping will work at first. In this case, what will firstly be needed is to begin with a 3D model with 3D stuff, so you can make a simulation of what will be the real arm in this case, because it is well to known that with this type of 3D modeling, with this type of simulations done before, there could be every sort of scenario considered, so you can then put it into practice and do it in the physical arm. So in this case, those are many of the things that need to be considered, so it can be possible to create one of these mechanisms. The other thing that has to do a lot with in this case with our major, is in the area of the programming of the arm, to make sure that it has the correct code and everything, so it can work always correctly, making sure that there is the specific instructions, the specific times where to do some stuff, the limitations, which is something that we are going to be learning all of the during our whole career. Even though this career doesn't have to do so much with the programming, still the few things that we have been learning and the things that we're going to learn in the future will make sure that we know the basics around it, and how to make sure that the thing that we're creating has its own programming made by us, and making the specific task that we wanted to do. So in this case, there's so many things involved in these cases, either not also with the programming, also with the wiring of everything, making use of sensors, making use of specific ways to trigger what the arm should be doing, to make sure that it knows what is he doing, if he already performed what task, and repeat it again and again, doing the specific code and all the instructions that have to do with it. So in this case, it will not be only to create and design the arm. It will also be to make the specific programming. So everything needs to be done correctly. And in this case, what something that also has to do, it's going a little bit to the mechanical thing about it, doing the restrictions and everything in the designing. We should be considering how much reduction do we want in one arm, how big or how heavy will the object that we want to move will be to one place to another, to make sure that the arm is sufficiently strong to perform this task, is something that also has to be considered and everything. Basically, what I can say from the major of Bachelor Mechatronics is that everything that has to do with the pre-do of the system or the machine or the mechanism that we want to do, everything that has to do with the simulation, with the programming, with the restrictions, with everything, is what it's the core of this type of projects or things that our major wants us to end up doing. These are the most important things to learn, and to make sure that everything is correct before going to a practice to the practice phase, since all of those calculations need to be at the very best and with all the precaution possible, so that it can be possible to make things happen. From experience part, I have learned so much that those mistakes done with the simulation or with the modeling of the object can create issues when you're doing it on the practice and everything. So everything must be taken into consideration. Applying everything that we have been learning on this class, in this case, for example, static balance, everything that we will know and learn about this in the few weeks that we have of the class, we are going to experience a lot of things that a person that studies mechatronics engineering needs to know, needs to take into consideration with real life examples. Everything that we are learning on the class, the topics, will need to be put on practice on this type of occasions. And this one, in this case, doing the project of a arm, which is with a specific instruction, is no thing different from what we will be doing in our whole careers, in our whole life. So this beginning with these type of things and knowing what we're learning in these classes is what gives you the opportunity to know more. And going regarding into some of the precautions or some of the recommendations that I will assume that needs to be taken into consideration, will be, in this case, as I said before, since one of the core things about this type of projects regarding a mechatronics engineer, it's to create the simulation and everything before doing the physical mechanism. That specific phase should be done correctly, step by step, and always taking into consideration everything, since there will always be room for things to happen, different scenarios to happen. And since you want to make sure that the arm is constantly working and is always doing the task efficiently and with no place for error and everything, this is the most important part of the project, which is the pre-do of the physical thing that you will end up doing. So that is one of the recommendations that I think it's one of the most important ones to keep on. Secondly, everything that has to do with the analysis of what is the task that in this case is has been selected to, either if it's to move one thing to another place, to just place a specific thing inside of something, just to move one thing, just to make a simple task. It should be really, really, really well analyzed. What does the mechanism wants to do? Once what is the specific purpose of these mechanisms, so you can find the best way to do it. And as I said before, since everything before it's the most important thing, it will also be the prototyping of the arm, doing all of the considerations needed, all of the ideas and have been proposed, to try them, to see what are their benefits, their disadvantages, what can happen, what cannot, every type of situation and everything, so you can do not have to worry once the arm is already done, the mechanism is already working. It should be, every precaution has to be taken, just so you can be confident that you're not going to need to make any maintenance again on that mechanism or any type of changes of it. So those things that do happen before the physical phase are the most important ones. Regarding the programming, I have been told the same advice in the past, and we always been hearing it. It's to go for things that are simple. There is no need to go out of what it's the normal basis. There will always be a easy, fast, and simple resolution to the problem that you have been assigned. And in this case, regarding the programming, regarding the wiring, regarding the mechanical part, everything will always have a simple and easy solution, so that you can continue with doing the project and everything working correctly. And another recommendation that I would like to give is to begin to analyze with other projects with similar things that you want to do, which is also a very good way to gain knowledge about what are you doing, what are things that have been done in the past, and try to begin from that place, since normally there will be the things that you would also like to have in your mechanism, taking those ideas from other already existing projects. It's something that helps you a lot to begin with a base of something that you think this one can perform my task correctly, and then begin from it doing more and more stuff. That is why also the prototyping is so important for this, since your specific task could be something that uniquely your arm is going to be doing. So that, for example, if someone else wants to do also these type of things, to say that you will need to make your own type of research and everything, because not all tasks will be the same in this case, since, for example, every type of movement in your arm needs to be considered, and everything that you want your arm to do needs to have the specific considerations. But going from a specific base of things that are already being done by other people will help you to gain some knowledge and some basis about it. There is nothing bad about doing these type of things. But yeah, that is basically I will recommend that everything that has to do before the producing or the physical phase of this project, everything that is before it's the most important thing that has to do with it. And I know that there will be many projects where these type of situations will appear, this type of analysis will need to be done and everything, so that the project can be carried on. So I hope that with this class and with everything that I will be learning on my major of the Bachelor in Mechatronics Engineering, I hope that we will be learning so much stuff and applying these type of things to real life situations like this one. I hope that we can make sure that everyone knows what he's doing, what are the things that need to be done, everything for our future and for several projects. So I did really like enjoy doing this video in this case, and I would like to make sure to keep on learning more and more about it. So yeah, that's basically it. Thanks everyone for your time, and have a nice day. Thanks.